Algebra 2. Today we're going to learn another factoring method called sum or difference of cubes. The abbreviation is just the first letter S for sum of cubes and difference of cubes, so SOC and DOC. It's an easy way to refer to it. What you need to know about this is first, sum means plus, difference is minus, so some of your problems will have a plus sign and some will have a minus sign. But the most important word here is a cube. And a cube is a power of 3 in math. So all of your problems, if they fall into this category, will have two terms, either a plus or a minus sign in between them, and both terms are going to be perfect cubes. And so what you'll need to do in your notes is make yourself a list of these. Perfect cube numbers are numbers like 1 to the third, 1, 2 to the third, 2 times 2 times 2, which is 8, 3 to the third, 3 times 3 times 3, 27, 4 to the third is 64, 5 to the third is 125, 6 to the third is 216, 7 to the third is 343, 8 to the third is 512, 9 to the third is 729, 10 to the third is 1000, and then the list continues indefinitely, but I just stopped it there. So if you start memorizing and know these numbers, these are the numbers you want to look for if it is a SOC or DOC problem. Okay, now these types of questions, it's all about pattern. Once you know what to look for, two terms, either sign, look for these types of numbers, perfect cubes, then the way you factor these is you always factor into one binomial and then one trinomial. So we'll make that note right here. You're going to factor into one binomial, which means two terms, and one trinomial, which means three terms. And so when you give me an answer for any SOC and DOC problem, you're going to see a binomial in front and a trinomial behind. Okay, so it'll be like a 2 by 3 answer every time. Again, there is a pattern to follow for these questions, and I'm going to model to you the example, and then I'll type it out. I want you to make sure that you're writing down all of the patterns, like the notes I make, into your notebook. Example 1 is x to the third minus 8. You notice that there are two terms. The power is 3, which is good. It's a cube. Powers that you want to look for in this method, or this factoring method, are 3, 6, 9, 12, multiples of 3. Notice that the numbers that you see are 1 and 8. 1 and 8 both show up in the perfect cubed list. So because of all of those things, that's what makes this a DOC problem, difference of cubes. It's important that you kind of ask yourself those questions and get that in your head, because soon we'll be mixing those up, like DOS questions with SOC and DOC, and you'll have to be able to categorize these, put them in a certain order, and that way you know what method to use. Alright, so here's how this DOC problem factors. First, you'll draw a small parentheses and then a larger one. In the binomial, the smaller parentheses, you're basically doing the opposite of cubing, which is taking the cube root. So you're thinking about this backwards. You're wanting to know what can you put in this first position of the parenthesis so that when you multiply this together by itself 3 times, it gives you 1x to the third back. Well, 1 times 1 times 1 is 1. X to the first times itself 3 times will give you x to the third back. So just kind of quickly making sure that you are following me as I say this. This is how you have to visualize it in your head. 1 times 1 times 1 is 1. x to the first times x to the first times x to the first. Again, remember you add powers when you're multiplying, and that will give you back what you had. And so all you're putting here is the factor that you can kind of visualize in your head that you would need to multiply 3 times together, since we're talking about cubes, to get this back. So it's essentially like the cube root. That's what it is. And then you're doing the same thing here, okay? But if you know this list and have it handy, this is easy. Your problem has an 8, and 8 is a perfect cube. I'm now asking you what number can be multiplied 3 times together and get 8 back, and that's going to be 2. So you're going to put the 2 right there. Whatever the sign is in the original problem, you always drop it down there. Now I'm going to take off the power of 1. You don't necessarily have to write it. So right now we're looking at 1x minus 2. In the trinomial, you're going to do the following. I'm going to type some of these directions out, and then I need you to copy them down, and then we'll go over where they go. Alright, so you are going to square, this is to get the second parentheses, square the first, change the sign, multiply together, always a plus sign, and square the last. Alright, and then I'm going to draw arrows so you can see where these go. So square the first is referring to this position. To get the first term in the trinomial for your answer, square the first means go back to the first of the parentheses, take the first term, which is here, and square it. So imagine doing like 1x times itself. 1 times 1 is 1, and x times x is x squared. Okay, so square the first goes there. The second piece in the directions says change the sign, and you're just going to follow that exactly. If this sign's minus, you're going to change it to the opposite. So you're going to put a plus. Third, it says multiply together. It's going to go right there in the middle. Multiply what together? You're going to multiply these pieces together. Okay, now don't necessarily worry about the sign, just do 1x times 2. 1x times 2 is 2x. That's what will go in the middle of your trinomial. Always a plus sign. Okay, well, just as it says, you're always going to put a plus sign at the end of every problem that's a sock or a dock. And then square the last. That is going to go in the last position. And square the last means you go back to your first parentheses, pick up this number, don't worry about the sign, just the number, and square it. 2 times 2, and put it here. I'm going to darken that in so we can see it. So that would be right there. So the final answer is going to be, fix this really fast, it's going to be 1x minus 2 times the quantity 1x squared plus 2x plus 4. That is how you factor a difference of cubes. Square the first, change the sign, multiply together, always a plus sign, square the last. Square the first, and notice I'm singing it like a sing-song fashion, kind of a pattern to get it in your head. And that's how I learned it as well. So square the first, change the sign, multiply together, always a plus sign, and square the last. Alright, let's try that again. This time, our problem reads, 27y to the third plus 64z to the third. Please notice that there are two terms in my problem. There is a plus sign in the middle. So like number one had a different sign, so this one was a classic example of a DOC, a difference of cubes. Well, this one has a plus. I do notice powers of 3 on the variables, and then I'm looking at the 27 and the 64, and I notice that both of those show up in my perfect cube list. I should have checked for a GCF earlier in this one. Luckily for me, I didn't have one, so I don't have to redo that problem. But remember, just like I've been saying for days now in the factoring unit, no matter what type of factoring problem you have, your very first step, like thinking process, should be, does it have a GCF? Because if it does, I need to take care of that first before I do anything else. And so I'm going to do that with number 2, 27 and 64. The numbers, the GCF of 27 and 64. So I'm thinking of a number that can divide into both of those. I do know that 3 goes into 27, but 3 does not go into 64. I also know 9 goes into 27, but it doesn't go into 64. And then 27 goes into itself, but it's not going to help me here. So the only GCF between these two numbers is a 1. Please notice that they both do not have the same letters, so there's no common factor. Alright, so back on track now. There was no GCF for example 1 or example 2. I can continue. This is a SOC because it fits kind of all the criteria here. And so I'm allowed to factor it into small parenthesis and a large parenthesis. And to get started again, we focus on the first term, and it's 27y to the third, and we're looking for like the cube root of that, what we could put here so that we could imagine it being multiplied 3 times together to give us 27y to the third back. And that would be 3. 3 times 3 times 3 is 27, and the variable would just be y to the first. So 3y to the first. Alright, whatever the sign is, you'll drop straight down in your first parentheses. Recall I did that in the last one. And now you're going to do like the cube root of 64. What number can be multiplied together 3 times to give you 64? If you'll look over here, it helps you. 4 to the third. It's going to be 4. And then factors of z to the third that are the same is just z to the first. And so in my first parentheses, I get 3y plus 4z. Now I'm going to follow all of these rules. And so we'll start with square the first. They're wanting me to square this piece. 3y times 3y. 3 times 3 is 9. Y times y is y squared. Change the sign. If this is a positive, we make this be a negative. Step 3, multiply together. Multiply what together? The 3y and the 4z. 3 times 4 is 12. Y times z is yz. Again, always put your letters in alphabetical order. Square the first, change the sign, multiply together. Always a plus sign. So we'll put a little plus sign here at the end. And then it says square the last, and the last is referring to this piece in the first parentheses. So 4z times 4z, and that would be 16z to the second power. And that's it, guys. It's, again, all about patterns. Once you memorize this in your head and you know these cubes, these problems should be fairly easy. Final answer, 3y plus 4z times the quantity 9y squared minus 12yz plus 16z squared. Square the first, change the sign, multiply together, always a plus sign, and square the last.